Today we are going to dive into the LeetCode daily problem, which is find first and last position of element in sorted array. So basically what is happening is that you receive as input an array of numbers and then you receive a target. You are supposed to find out what is the last index of that target and the first index of that target in our sorted array. So it look like easy, right? That you just need to take your array like this, for instance, look through your array from left to right, and when you find the first element corresponding to the target is actually the left, and then you will continue. When you find the last element, it corresponds to the right element. But there is one problem here. We want you to have that algorithm in big of log of n. This is where the interesting part of the algorithm starts, right? So you can't allow yourself to look from right to from left to right. You need to go with a binary search approach, because we know that the binary search approach helps you to find a position of an element into a sorted array, and our array is actually sorted. Now, how are we organizing ourselves to have the first and the last element using binary search? That is what we are going to see in this algorithm. So if you are new here, don't hesitate to subscribe, like, and share, because here we are doing LeetCode daily. We are doing occurring solution. So if you're someone trying to increase or to go to the next level in terms of data structure algorithm, don't hesitate to subscribe, like, and share. Okay, so let's dive into our core algorithm. Before even we do so, let me give you some example. I just share with you one example here. Let's say you have an array like this, right? And then you want to return the left and the right, that means the first and the last position in this array. So the solution is actually 3 and 4. Why 3 and 4? Because if you look from left to right, this is position 0, position 1, position 2, position 3. That means 3 is actually the first occurrence of the target 8, and then 4 is actually the last occurrence of the target 8. So I forgot to say our target here is 8. Nice. So now, like we said, since we are aiming to have an algorithm of log of n, how are we going to solve it? So let me explain you what does the binary search look like the basic binary search. So in the binary search, you have an array, sorted array, and you're supposed to find the position of an element in the array. You are going to have the left element being at the leftmost position, and the right being at the rightmost position, and then you are going to have what we call the middle element. So this middle element is going to take the middle of this array. What does that mean? That means, okay, we are from left to right, so the middle is actually the left plus the distance in between those two divided by 2, right? So in this array we have 0, 1, 2, 3, 4, 5. The middle element will be 5 minus 0 divided by 2. So it will be 5 minus 0, which is 5, divided by 2, plus the left. So 5 divided by 2 is actually 2. So left will be 2. So basically you are going to 0, 1, 2. You are going to position your middle here. You are going to check, is this middle actually equal to the target? No, it's not equal to the target, since our target is 8. Now we are going to check, is this middle actually less than the target? If the middle is actually less than the target, that means our target is definitely here, or it doesn't exist in our array. So what you're going to do is that you are going to ignore all the elements before this your middle element. So you are going to move this pointer to here, to left plus 1, to middle plus 1. So left is going to take middle plus 1 in the case where the target element you are searching is actually greater than the middle element that you found. In the other case, if it is inside smaller, that means it is not in the bigger part, it's inside the small part. In that sense, now you are going to move inside the right element to the middle -1. So the idea here is to take initially an array of elements and keep breaking the algorithm, in fact keep breaking the array into halves of what we were having previously. That is why we are ending up with big of log of n. So this is the idea of the binary search. But here in our situation, we are not going to just rely on applying the binary search, because we don't just looking for the element, but we are looking for either the first occurrence of the element or the last occurrence of the element. So by what I just described here, you can see that if you want to implement the binary search, here you will have to just return the result when you find it. And then if the middle is actually less, you shift the left, as I was saying, to middle +1. Like I was saying, you shift the left to middle +1. Otherwise, you shift the right to middle -1. You shift the right to middle -1 if it is the lower bound. Now we are not just in that scenario. We want to have either the first or the last. How are you going to modify? We are just going to make it this way. So basically what we are going to do is that if we find an element, good, we keep it. But we don't just rely on that okay, we have the element. We are going to say, okay, if the position is actually 1, that means if we are searching for the rightmost element, so after finding the element, you should put the left to that middle +1 for you to search if you have another of that occurrence into the rightmost part of the algorithm. What does that mean? Let's say we found this as a solution. Let me grab another color. Let's say we found this as a solution, right? And we are in a situation where we are looking for the rightmost element. So what we are going to do is that we are not just going to rely on this. We are going to keep this. But after that, we are going to continue the search into the rightmost part. That means into the middle +1. You see, the left is going to take the middle +1 into the middle +1 till the right. That means if you have any 8, which is after the one we previously had, it will definitely be in this array. And then applying the binary search into this subarray will actually return us the rightmost 8. If it's not the rightmost 8, we are going to continue until we have nothing. And then when we are going to have nothing, that means when we are going to find ourselves into a subarray where there is no 8, the fact that we keep it here will actually be returned here. So basically that is the idea here. I hope this explanation was clear to you. I hope you do enjoy it. Feel free to leave me any message, any comment. I'll be really happy to interact with you regarding this. So let me submit. So you see, so this is how it performed. So thank you for listening to me. I hope you do enjoy it. See you on the next video. Ciao.